Okay, so let's start with today's first question. So basically, what the ask of the question is that you need to find the lowest common ancestor in a binary tree. Okay, so what does that mean, first of all? So let's say you will be given a tree like this, right? 5, 2, 3, 4, 1, 7, 6, right? So this is the input. Okay, we already know ancestors are all the predecessors of the binary tree. For this question, there is just one exception, that the node itself will also be called as an ancestor. I'll tell you how. So for example, if the two nodes that are given to you are LCA 7, 6, okay? 7 and 6, you need to find the lowest common ancestor between these two nodes. How can you find that? So if you see, right, for 7, what are its ancestors? First of all, I told you the usual definition of ancestors. All the predecessors will be termed as ancestors, 1, 4, 2, 5. Just for this question, what they have assumed is that for 7 itself will be a ancestor. So the node itself will be an ancestor to that node. Only for this question they have considered. Otherwise, that is not a usual definition. We'll see how that is relevant. But for this question, I mean, for this ask, let's say, what will be the answer? Now, if I have to say for 6, right? First of all, the usual ancestors are 1, 4, 2, 5, and 6. So if you observe, what is the lowest common ancestor between them? 1, right? So if we have to calculate for LCA and 7, 6, the output will be node 1. Does that make sense?
What does the term lowest actually mean? The lesser value or the last level, something like that?
So it means basically, how do I say? So it has got nothing to do with the value. It has just got to do with ancestor levels. Okay, so basically this is level, this is another level, this is another level, this is another level. Which is the lowest level ancestor? Or basically the first common ancestor. You can call it first common ancestor.
Oh.
No, nothing to do with the value, just first common ancestor between the two nodes. Similarly, if I have to find LCA between 6, 4, what will it be? 6, 4. Okay. For 6, right, what are the ancestors? 1, 4, 2, 5. 6 itself is one ancestor, right? For 4, 2, 5, and 4 itself is one ancestor. So you observe, right? If I wouldn't have taken this 4, I mean, I couldn't get this common ancestor, right? I would have said 2 is the common ancestor. But for 6, right, 4 is its ancestor. So you need to return 4 here. Are you getting what I'm trying to tell you? See, for 6, right? So so far we have assumed that the node itself is ancestor. So for 6, right, the combination or the list that we will get will be 6, 1, 4, 2, 5. Okay. For 4, what will we get? 4, 2, 5. Now, if you observe, what is the first common ancestor that you can get? The first common ancestor that you can get is 4. Are you following the question? I mean, this question is very important, actually. So we'll try to generalize what all cases can appear, but I'm just for the sake of understanding of the question, I'm taking these examples. So 7, 6 is clear. If we had here 6, 4 is clear. How about 1, 3? So for 1, what are the common?
Sorry, Afnan, can you again explain this 6, 4?
Okay. See, for 6, 4, right? So first, for example, if you go back to the first lecture of the tree, what did we say? That all the predecessors are ancestors. So let's say that we remove this 6 for now and we remove this 4 for now. So I'm saying for all the predecessors of 6 are its ancestors. So what are the ancestors? 1, 4, 2, 5, right? 1, 4, 2, 5. And for 4, right, it will be 2, 5. Now the question says that the question's expectation is that the node itself is called its ancestor. So that means for 6, right, the ancestors will be 6, 1, 4, 2, 5. And for 4, the ancestors will be 4, 2, 5. Now, if I have to find the first common ancestor in a binary tree, right? So just go through the list and just see which is the first common element between the two lists. And the first common element between the two lists is what? Nothing but 4. So the answer for the common ancestor between 6 and 4 is 4. Does that make sense? Okay.
Yes, but how 6 would be the ancestor of itself? That is.
Yeah, that is what I'm telling you. See, ideal definition is that all the predecessors are its ancestors. Yeah.
Mm-hmm.
But for this question, I mean, the assumption is that that node is also called its ancestor. So had you not included this 4, right, and 6, right, the answer you would have got is 2.
2, yes.
Right? But that is not the case here. The expectation is that if the node is to be considered, right, then that node is considered as its ancestor as well. So in that case, the common ancestor between the two will be 4 and not 2.
Okay.
Okay, for 1, 3, how can you find right now? So for 1, what are the ancestors? So 1, 4, 2, 5. For 3, right? 3, 5. So basically 5 is your answer here.